Okay, so we're going to start looking specifically tonight at the detail drawings that we're going to be creating, not only for the parts, but also for the assemblies, and also specifying tolerances and fits. These are the last 3 assignments for Module 2. So once we have all of our parts modeled, we have the assembly all put together, now we're ready to kind of, if you would, put it in the format that we can release it to production. Production needs drawings so that they can understand the requirements for manufacturing so that it's going to fit together. So, so what we're going to do is we're going to look at the detail drawing assignment first, and then we'll kind of go from there. So as you know, when you created your models, you save them as part numbers. And in this assignment here, you can see the part numbers that correspond to each one of the parts, okay? You'll notice that I did give more points to the frame just because it's a more complex part. There's more features there. There's gonna be a lot more dimensions, spending more time, more views, all that kind of stuff. So that one's worth 20 and the rest of them are each worth 10 points each, okay? Now, the information about the sizes and such are going to be in this module, I'm sorry, the Arbor Press detail. And this is that original kind of project sheet that I gave you. So as far as modeling, we got all of our information off of here. And you can use, you know, obviously the dimensions, the number of decimal places as a guide to create your detailed drawings, okay? So, so this is a great place to start. But then we have to ensure that things are going to fit together. And we have to ensure that we're dimensioning to the ANSI standards. We can't be putting it in a 3D view like this. We're gonna, you know, lay it out in our 3, you know, views, 2, 3 views so that we can properly orthographically project it with the dimensions on it and then add the dimensions from there. So this is kind of like our starting point, if you would, okay? I also have out here for you drawing guides. Now, in the past, my expectation was I wanted you to follow the drawing guides to a T because you were early on in your dimensioning journey, if you would. But now you've got some time, experience underneath your belt. But I also realized that you probably want something to just peek at and make sure you're on the right track. Or if you're not quite sure about something, see how somebody else did it so that you can continue to make progress. So the guides are out here for that purpose. My expectation is not that you're doing it exactly like it because maybe you picked to dimension something differently. And as long as it is to the ANSI standard, okay, you're fine. All right. But if you deviate from that, or if I see issues with that, that's when you're going to get, you know, some red marks and such. You will still have 2 attempts to make corrections. So even if you don't get everything perfectly correct the first time, you still have the opportunity to go back in and make corrections for the points back within our 7-day grace period. Now, again, the first due date isn't until next week. So we kind of have, like, if you would, 2 full weeks to get this done. Okay. So I'm not going to start at the top. And what I did do is I have these underneath my camera right now. So what I want to do is kind of over here and we'll kind of get started with things. So I'm going to go underneath my camera right now. Got to get my camera up and running. Sorry. Okay. And what I did was I printed out these drawings. You guys do have them in PDF format. So feel free to just pull them up on the computer and then reference them as we go. But I wanted to talk about each one of these and kind of what the expectations are. Now, again, this is my drawing guide. If you chose to kind of show this differently, but you're still getting the same information across and you are abiding by the ANSI standards, that's totally fine, okay? But you can't go rogue and start just saying, well, I think it would look better like this, all right? So just make sure you're doing that. Now, a couple things here. This is our RAM, all right? So these were those 22 teeth, 20-degree stub gear teeth, and they're that 12 pitch. You'll notice that I did do a detailed drawing so I could add the dimensions for 1 tooth. And then that way it would be repeated according to our note 22 times, okay? Also where the start of that tooth is, all right? So these come from the sketches that we made to create this. Detail view. A detail view, you're going to be in Creo on the layout tab when you're doing a drawing on that very first tab all the way over to the left. I believe it's called the layout tab. And there is a detail in there. And then it does a pretty good job of giving you the notes on how to do that. And I think you guys have done the detail drawings before. So you would want to lay it out in that fashion. Now, as we look here at the length, the height, and the width, the length itself, not very critical. Notice that that is a 2-place decimal. I hope you can kind of see that, 7.75. Again, going off of what is in the detail drawing that we, or that overview sheet that we have. But when we look here at the 0.75 and the 0.75 on the height and the width, if we go to, I'm going to go back into Canvas and look at our tolerances and fits assignment, you are going to find, oopsie, I thought there was a, this always looks a little different. I've got to go into the student view so we can see. And I'll go down there, sorry. Up on the top of this assignment, when you pull it up, the first 2 items that are here, the width of the RAM and the depth of the cut in the RAM recess on the frame needs to accommodate these 2 dimensions. So what we need to do is you need to add tolerances to the height and add tolerance to the width. See, add tolerance to the width, so that it's going to fit together freely, but not too much slop, if you would. Okay. So because you know how this works, when we rotate that handle, we want this to move up and down freely within that recess on the frame. So you need to figure out what type of a fit do you want to use for this. And if you remember, there was running clearance fits, there was press fits, there was those transitional fits as well. So thinking in those terms on how it's going to function, I'll tell you for this one, you want to use a running clearance fit. Okay. So if you go over to this assignment, these first 2, if you go to, going into that, I'm going to say in air quotes, that quiz, this assignment, the first 2 items here, the width of the RAM, you need to determine what the basic size is. It's going to be 3/4 of an inch. You need to pick a class of fit. Okay. So when you go to those charts, remember those kind of orangish charts that we had, and we had the explanation of the fits. You want to be sure that you're lining up what you believe the function of that part is going to be with the type of fit that is identified there. Okay. Now, when I'm looking around in my room, I see some nods, but does everybody understand what I mean by that? Okay. So once you pick your fit, then you are going to be identifying what the limits are on the rack recess. That will be the hole. So the part that you're taking material away to accommodate, that's going to be the hole. That's going to be on the frame. And then you are going to get to the rack width, which is what we're looking at right here. And you are going to determine what the limits are there. This is the shaft. This is the external feature. This is the internal feature. So the hole, even though it's not round, this is a rectangular cut. This is going to be the rack recess. And then the RAM width is going to be the shaft. So if we go back underneath here, this is what I'm calling the RAM width. Okay. This, you are going to add a tolerance, and I'm going to say, you're going to show me the limits. Because remember, those charts, when you go off your basic size, and you pick your fit, your RC2, RC6, whatever it might be, you go down to the column, you go down the column for the hole. And now it's going to tell you +1, -0, or whatever that is. You're going to apply those limits, or you're going to apply that tolerance, and you're going to show the limits. When I say a limit dimension, that means that your dimension is going to be to 3, maybe 4 decimal places for the top, and that same amount for the bottom, whatever it would make sense to be. Okay. Sometimes it's 3 on those charts. Sometimes it's 4. Okay. And that's the type of dimension you want to put here. So 0.75 is going to be your basic or nominal size. And then once you decide what your fit is going to be based on the descriptions, You're then going to apply those tolerances and determine the limits. The limits are the dimension that's going to go up here. Okay. Then you're going to do that very same thing for this dimension. Okay. You're going to apply the limits because this is going to be now, you know, how deep that recess is going to go in the frame and how deep then we can actually make this. This is also going to be based. I would probably use the same fit for both of these, quite honestly. Okay. It makes sense. Once you pick the fit for one direction, it's going to be the same for the other. Okay. So that's how you pick that for that. Now, I've been pointing here and we haven't used actual numbers. Is there anybody who has any questions about what's the expectation there? Okay. So when you hand in, you are not leaving these two dimensions as 0.75. I'm going to see those as limit dimensions based on your fit. And you're going to document the fit in number 1 here. It's worth 8 points, 2 points for each one of these items. And then in number 2, that's going to be the depth cut, or the depth of that cut. And that's going to be here another 8 points. And these numbers are going to be what we're going to see on the drawings. Okay. All right. I'm just going to peek at our chat. Basic whole system. Absolutely for all, Lex. Thank you. Yeah. So go right along with the chart. We're not going to do shaft. James.
For the rod.
If you kept the knurl for the rod, okay. Yeah, then you would have to do it on there. I don't have a place for you to document that, but yeah, you would have to put a press fit in then. Yeah, if you do that on the knurl. So on the ends, and what you're referring to is the what James is referring to is the handle and the handle caps and the lever arms. There's 2 caps that go on the ends. As we had talked about previously, I modeled mine as threads. Okay. I just kind of figured then I can take them on and off more easily. But if you press them in, then they're in for life. Okay. And that's okay. That's all right. You're the designer. All right. So fill in this and then apply that to those 2 dimensions on that drawing. Okay. Any other questions about the RAM and the RAM and the rack recess? When I talk about the rack recess dimensions, I'm gonna have to pull this guy up. And I know it's hard to see all these dimensions here, but where that is on my drawing for my frame is going to be this width right here on the width of where that rack goes down in. This is going to be then your whole, I'm calling it whole in quotes from that chart. This is going to be a limit dimension, okay, to correspond to that fit that you picked. And then this dimension right here is going to also be the whole dimension for the limits on the depth of that cut. Okay. They grab the dimension. If you remember, it was like this. This was the width over here, but we're gonna put it up here. Okay. All right. Okay. Any other questions on that before we move to the next drawing? Okay. All right. Cool. So this one's we're gonna bring back and forth a couple times. Okay. So our next drawing is going to be our pinion. Okay, our pinion shaft. So the pinion shaft, as we know, this outside diameter, the larger diameter, 1.167, is larger than what was identified on our print. So in this case, over here, the diameter that they had was, nominally 1 1/8 inches. But when we did our spur gear teeth, this came out to be 1.167. So as we had stated, we did not model it to this size. We modeled it to the size that the outside diameter of those spur gear teeth came out to be. And then we have to now apply a fit to accommodate this outside diameter to the hole that goes through here. Okay. And it's actually this hole over here if we see the cross section. Okay. So you'll notice that on some of them, I'm going to tell you not all of them. So just be aware, this dimension right here, it has 2 little asterisks by it. It just kind of is, kind of letting you know that's not the dimension. This is just the nominal size. And then you're going to have to apply the fit to accommodate that. So you're going to go through that same process again. When you look at the shaft diameter here. This is your nominal size, even though it's not a, nice, even incremental English system number, this is still your nominal size for which you're going to apply then the tolerances in the charts, okay? Now, the fit for this, probably a little bit different, probably closer clearance fit. You still want it to go in easily back and forth, but you want it to run nicely. I would probably do a more accurate, a closer fit than what your RAM was, okay? For those who happen to be here in class, we have the examples, of the arbor presses up in front. Feel free to take those apart, kind of feel what you feel like is there, and then, get a feel for what you think the value would be. So this dimension here, you need to tolerance and then put limits in, okay? So you're gonna have something that is gonna be 3 or 4 decimal places, high and low value here for that, okay? This is for the outside diameter, and then you're gonna have that very same thing here, okay? This is gonna be adding a tolerance here for the diameter as you go through, and then this is gonna be the 3/4 inch nominal size for that smaller, I think we called it the shaft diameter of that pinion shaft, okay? So here again, if we go back to this tolerances and fits assignment, here is that third question is going to be the pinion shaft diameter to the bore in the frame. And then the other one, skip one, it's going to be the pinion shaft extension to fit within that shaft bore. Okay, so this is going to be numbers 3 and 5 for those two that we just saw. Okay. Now the collar in between, the collar ID, which is the inside diameter, has to fit over that shaft extension, the 3/4 inch diameter. So if we look back underneath here, this part of our shaft, first it's got to go through that hole in the arbor press, but then we have to fit that collar over the top. Okay. So once you determine what these tolerances are here, this is the shaft part, you're going to use the same fit for, find my collar, hold on, a little bit further down the road here. It's going to be the same for the collar. So this diameter right here needs to fit onto the shaft diameter. So this tolerance here is going to be the same fit as it was for this one. It's going to have the same values. Okay. Limits again for that. And for that one, you're going to identify, that's going to be number 4. So for number 4, basic size, what class of fit did you get? And again, it's going to be the same as the one that you did earlier. And then you're going to show me and identify your collar. ID is always inside diameter in case you're not familiar with that. OD is outside diameter. So that's the inside diameter of that collar. Okay. All right, questions on that? And now as we look at the rest of, the other dimensions, the ones that I'm not, focusing on that aren't fitting with other things, you just put whatever the number of decimal places was on the drawing here, but you have to be aware of your title block. There are some 4-place decimals on this. There are some 4-place decimals on this. Don't put anything as a 4-place decimal without a tolerance on a drawing, because our title block only has 1, 2, and 3-place decimals that any tolerances or any dimensions without a tolerance on it are going to default to your title block. That is probably one of the things that I know it's easy to forget, but you put the 4-place decimals, that's what it said there. But then the next thing I'm going to say is, what's the tolerance? And you're going to say, well, yeah, it doesn't go to the title block. So make sure that if you leave anything without any tolerances in back of it, every dimension has a tolerance and it defaults to the title block. Okay. All right. All right. So then I'm going to put this one. Any questions on, I guess it would be the pinion shaft, collar, and then where it's going in the frame there. All right. Let's see what we have next. I'll put this one to the side. Let's just go past this one for a second. I'll come back to that one because that's a GD&T calculation one. So I want to make sure we have a little bit of time to look at that. All right, our next one is the table plate. On the table plate, the note that was on the actual little illustration here, it said we wanted to grind both faces. This is where we're going to be like setting stuff down on, right? So what we want to do is, this is a cast piece. And you'll notice that I put on here a flatness of. The flatness that we have here is a refinement on what the tolerance here. Now, width of this, probably not as critical, but we want it to just be nice and flat. And then we want the other side to be parallel to it. That's what the grinding on both sides. To achieve 2000s flatness and then a parallelism within 2000s, you're going to need to do a grind, okay, on there. So notice that on one side, we qualify the surface, we make it nice and flat. It becomes a datum, okay? And then the other side is going to be parallel to it, all right? So in Creo, you're going to notice that on the annotations tab, there is a GD&T section. That's where you're going to see that. If anybody needs help with that, because you should have gotten that experience before, but if you do need help with that, let me know, and I'm happy to do some of those demonstrating during our lab time. Okay. But I'm pretty sure you guys have been really good about, you know, being intuitive and kind of remembering how that stuff works. Okay. The other dimension that we have on here that we want to be aware of, you want to add a tolerance here for the inside, this little hole that's on the inside, you know, of our table plate. This is going to have that pin. So remember that little groove pin is going to press into there. So I just got to find my little groove pin. We are going to tolerance that hole to fit with the outside diameter of our groove pin. Okay, now here, how is that fit going to work? This fit is not going to be a running clearance fit. This is going to be a press fit. Okay. So those are FN fits. Okay. And what you're going to want to do is read the descriptions. Does this have to be super tight where I have to, you know, really pound it in? No. All we want to do is make sure that when we press it together, that they just stay together. We don't need to, you know, heat up or cool down one element or the other. Okay. We just want a nice press fit. And if you look at what we have here in the room, that's exactly what they have too. So read some of those if you need some guidance, but what's going to occur is that our shaft, this diameter, is going to be larger than the hole. Okay. So again, this is going to be an FN fit with that groove, and you're going to identify the limits, of the hole, and then limits of your shaft or your pin. Okay. With those tolerances. We go back to the assignment. Let's go up to the top here. The last two are going to be, it looks like, oh, I'm sorry. This, the second to last is going to be the groove pin fit into the hole of the table plate. Okay. That's going to be the press fit there. Let's look right away at the groove pin fitting into the base of the frame. Okay. So in this case, it would be an interference fit, an FN. Lex, I just saw your question. Do we want to do an LN? No, you don't want to do a, you don't want to do an LN because that's going to be at times not an interference. Okay. And we want a little bit more of the press than that. We don't want it to come apart or have the ability over time, or even if the temperatures change, for it to come apart, because some of those transitional ones are going to be very light interference fits. Okay. So let's go and look at the frame and this pin. So when this gets pressed into that table plate, we are going to have a little assembly like this. So that's going to be, they're going to be together. They're not going to come apart. Okay. And that little part of the pin is going to be sticking out so that it's going to fit into the hole that is in the base. Okay. And I just got to find, okay, down here on the bottom, I have that diameter picked out. That's where I chose to put this diameter. Now, this is a very forgiving size hole. So the nominal size of our pin is 1/4 inch. This is 0.265. You're probably not going to find a fit that is that wide. That's okay. Pick the most generous running clearance fit and apply those numbers. Don't worry about what's there. Okay. This was just their idea. We're using the charts. I want you to get that practice on using those charts. So you're probably, like I said, this is going to be on a, nominally on 1/4 inch. That's going to be 15 thousandths. You're not going to have any running clearance fits that are that big, but pick one of the larger, more generous types of fits and then apply those tolerances to it. So you still are going to have a nominal or a basic size of 1/4 inch, but this diameter is probably going to change on you. Okay. And you're going to show those limits again. So this is going to be limits here as well, but it's going to be a clearance fit, a very generous clearance fit. I know, Lex, I think you asked that question when you sent the email to me. So does that help to answer that? Yes. Okay. Yeah. All right. Let's look at some others before we look at this guy. Let me see where we're at, kind of catch myself up. Okay. So I know we talked about this guy. We'll talk about the assembly in just a little bit. We talked about the pin. I want to put that on the side. We talked about the table plate. Now, GD&T that we're applying, you're going to notice we're not going crazy with it. Okay. We're just kind of putting it where it seems to make sense. There are some drawings that don't have any, and that's okay. But you want to consider it, in most cases. So like, for instance, when we looked at, and this said grind on both sides. Well, to get that with a regular dimension, we would have to put this down to like 4 decimal places. All right. Well, now we are restricting the height of that part, which is hard to actually machine. This way, we still have the height plus or minus 5 thousandths. That thickness can go up and down. All we want to happen is now let's take a nice grind off of that surface so it's nice and flat. And then let's go on the other side, turn it over and make it nice and parallel on the other side. That's only 2 extra operations rather than trying to dial in and taking your time to try to get this to a really small width tolerance, if you would, a really tight tolerance on the width. So, so this helps us. So only there, but then you'll notice that I didn't put any personally on my lever rod. Okay. There's really not much here in terms of, and especially when we look at how it's going to fit into that hole, there's not a whole lot. It's not real critical, right? So, and I'm not going to say that GD&T is all about being critical, but this is going to be totally fine. All right. We don't have to worry so much about the GD&T on that. Okay. So, so that's the lever arm, nothing special there, if you would. We did talk about the collar. This is that handle cap. Okay. Now here in the handle cap, what they did, they really didn't give, I don't think, hardly any detail. Oh yeah, they did. They did a press fit on the inside of that hole, and then they knurled the outside or the ends of that lever arm. Okay. So a lot of people were asking about that. If you want to use that as your scheme of putting it together, that's okay. But I chose to do the threading. Okay. So you're going to notice on the ends of mine, these are threaded to 1/2-13 UNC, and I did it about, what is 0.43, 7/16, I think, ish. Yes.
There ever any benefits to doing knurling instead of threading?
No. When you knurl it and you press it together, just keep in mind, you'll never get those handles off again. The handle is there then, it's going to stay. And that might be something that you're like, yeah, I want that, because a couple times when I was using the assembly here, because it doesn't have any caps on the ends, I twisted the thumb screw and it just like fell off. It just fell out. Okay. Which I didn't really like so much, because at least if the handle cap would have been there, it would have stopped it from falling on the floor. So, So functionality wise, I think the caps are a good idea, but doing one way or the other, which do you think is the cheaper way of manufacturing this? Threads or press fit? Probably the press fit, but then you got to think a little ahead too. Is there ever going to be a reason that I would want to take that handle off? May or may not. I don't know. So then having threads gives you that opportunity to disassemble if needed. Okay. You're the designer. You get to make that. You could do a press fit on one end and a thread on the other, right? You could do that too. So that's kind of the fun part about the design. Okay. As long as it's going to fit together, as long as if you choose a press fit, then you're adding a fit. It's that which isn't required in the assignment, but now you do have to, you know, put an interference fit there. Or if you wanted to go with the threads, then make sure you have an internal and external thread that are going to go together. Okay. All right. Okay. So that's the handle cap. Oh, the thumb screw. The thumb screw here, again, nothing too special about it. The one thing that I did put on here, because when we're looking at pieces that we potentially are going to be, you know, handling with our hands, when we have parts like this that are made out of metal, the ends, it can be sharp, okay, to kind of deal with. So I did put a little note on here, break all sharp corners. So it might be like just taking a little deburring on the edges so that when you pick that up and you kind of use it, you're not, you know, cutting your fingers on there, which can very easily happen when you've got metal that has sharp corners, okay? Even though you'll notice I didn't put any chamfers in there, just this note kind of lets them know, you know, just kind of, you know, be aware of that. You don't have to do it on everything all the time, but if there is something that you're going to physically be handling, it's a good idea to do that. Okay. Yeah, this one's just kind of the basic dimensions, you know, and it's really not very critical. It's going to be what we use to actually keep that handle from, you know, going like sliding in and out of that hole. Okay.
For the material, is it fine if we just put steel instead of anything?
I'm not opposed to that. Yeah. If you just want to put generic steel, that's fine. Yeah. Yeah. Other questions? All right. I'm sure that as you start working, things will come up. All right. And that's okay. That's fully expected. And that's why I just wanted to kind of give you an overview and show you these before we, before I set you free to start working. The last detail that I want to look at before we worry about the assemblies, I might do a separate, I think, for the assemblies. The last one that I want to look at is going to be the faceplate. Okay. And it just occurred to me when I was looking at this. Maybe it's not a big deal. Okay. I want to look at the GD&T here. This is the one place that we are going to, and you will apply positional tolerancing. Some of you, it's been maybe a little longer than others since you've had GD&T. So I want to go over position tolerancing again and, you know, talk about what we have here as far as the calculations and the numbers. And you know what, with that, what I think I'm going to do is I'm going to end the video here and I'm going to have a special video just focusing on this and the equations so that we can just kind of revisit and remember how to approach this. So I'm going to stop this video here so it can be its own.